Hi friends, Naji here. Welcome to my YouTube channel. So in this video, we'll be discussing on a very important topic, that is REST ownership. First, we can see some of the definitions and some of the rules with respect to REST ownership. Then we can do some practical examples on that. Okay. So REST ownership is actually help us to write high performance, memory safe code without garbage collector. The ownership is REST way to tracking who is responsible for a piece of memory at a given time. Okay, so that is a basic definition about the REST ownership. Then we can see some of the rules, and these are the very important rules. Okay, so each value in a REST has an owner, and there can be only one owner at a time. So this is very important feature, that is there can be only one owner at a time. So when the owner goes out of scope, the value will be dropped, the value will be cleaned up. Okay, so that is how the REST memory is handling. So for example, if we have a variable, so variable is goes out of scope, then REST will automatically trigger a drop method, so which means the garbage collector cleanup, not a garbage collector, memory cleanup. Okay, then it will automatically clean the memory for that particular variable. Okay, now we can see some practical example how this works. Okay, so let me go to my Visual Studio Code. Okay, so this is my Visual Studio Code. So I have my one of my project is open in the main.rs file. Here we can see I have declared a variable called let s is equal to hello, and I have print the particular variable. Okay, so we'll see how this works, right? So I can use cargo run. I'm going to run it directly, but I'm getting an error. So let me see why this error, because I am using the semicolon. Okay, again let me run it, and we can see that it is working fine. Okay, now since it's a variable, let me create another variable that is equal to s1. Okay, here I'm going to assign this into s2. Now let's print this again. I'm going to print s1 and I'm going to print s2. I mean both s and s1 I'm going to print here. Let me save it and I'm going to run it. Okay, so if you look on this here, this is working as we expected, right? Both s and s1 are printing perfectly fine. Okay, good. So this is working because these are the string literals, and these variables are, so for example, if is let s is equal to hello, which means a compiler knows that this exactly need 5 characters, right? Now consider another scenario, a dynamic allocation case, a heap memory allocation case. Okay, for example, we are fetching, or we are asking some value from the user, and user is giving some kind of input. Okay, so in that case, our compiler does not know about the size of the memory that need to be allocated. Okay, so we'll discuss about that particular scenario, and we will see what is the difference is happening. Okay, for that let me remove this. Maybe I will do a comment out here. Let me do a control set. I'm coming the code, so we can use the star hyphen to comment the code. Okay, now let's create a variable called s1, and here I'm going to have it like from hello. Okay, so in this scenario we are allocating this s1 to a heap memory, and actually this s1 is a kind of a pointer. Okay, so if you declare something like this, what is actually happening under the hood? Okay, let me go back to my slide. Okay, let me take this particular screen. Okay, so here we can see we have created a variable called s1. Okay, and s1 has a pointer that is point to some memory location. Okay, so it has an index and value will be hello. Okay, and we can see that this is a pointer pointing to a memory locations, and it has a length, and the capacity is also mentioned here in this s1. Okay, so that is how actually happen here. Now let's print s1. Okay, please be patient, you will get to know like what I'm trying to explain. Okay, now let's execute this. I'm executing. Okay, this is actually not dot, this is column, and execution is fine, and we are getting the value s1. Now, who is the owner of this memory location? So if you look on this, the owner of this memory location is the s1. Okay, now let's create another variable, just like as we did earlier. Let's create a variable called s2. Then I'm going to assign that s1 to s2. Okay, now let's print the s2. I'm going to copy this, paste it here, and I'm going to print this. Okay, executing. S1 is equal to s2. Could not compile the ownership due to one previous error. Should be, let me check this one. Okay, let's remove this print now and let s2 which is equal to s1 and print s2. Okay, so here I forgot this particular semicolon. Let me do it again. Okay, now we can see that s2 is print successfully. Now what is happening under the hood? Okay, so let's go back here, go back to our slide, and here we can see, let me maximize. Here we can see we have earlier we have a s1 pointer that is pointing to a memory locations, and we have another pointer that is s2 that is also pointing to same memory location. Okay, so earlier the owner was s1. Okay, now after assignment, it is the owner is actually s2. Okay, as per the rule, so if you guys are remembering these particular rules, there can be only one owner at a time. Okay, so that is the basic rule with respect to the Rust programming language or Rust ownership, right? So this will not work for sure. Okay, so why they are keeping only one owner at a time? So I will tell you like one example. Consider one example. In this case, we have s1 and s2. Okay, we said that whenever any one of these going to out of scope, it will call the drop method, or it will try to clean the memory. For example, in a particular scenario, okay, s1 is going to out of scope, or it is now it is out of scope, right? So what happened? So s1 is out of scope, then Rust program will by default will call a drop method to clean up the memory. Okay, so this it will try to clean up this memory. Okay, then next time, then s2 is like in a out of scope, then it will again trying to clean up the same memory, right? So in that scenario, there will not be any memory to clean up, right? So this is called the double free problem. Okay, to avoid this, the Rust is keeping only one owner at a time. Okay, so in our scenario, what is actually happening is, okay, the slide is not added. So what is actually happening is, when we assign this s1 to s2, the ownership is changed from s1 to s2. Okay, then we will not able to access the s1 anymore. Okay, for example, if I do a println with respect to s1, I'm going to print it again, and let's see how this work. Let me save it. Okay, so we are getting an error saying that the ownership error. Okay, so what it says is, instead of just assigning this, just do s1 clone. Okay, so if you do like s1 clone, then that is a different story. It's not the assignment, it's actually cloning is happening. So that is an entirely different one. So here we can see s1 and s2 both are working perfectly fine. Okay, so this is the basic concept with respect to the ownership. Okay, now let's see what happens if we pass this variable to another what we call another function. Okay, let's discuss that also. For example, if I have a variable called s1. Okay, similar to earlier, I can have the s1 and hello will be there, and I'm calling a method. Maybe I can call it like here I am println. I can do a println. I'm going to print s1. Okay, in between I am doing some change, right? I can call some change, and I am passing s1 here. Let's define a function, some change, and I am expecting a s2 Okay, then I can do a println s1. Let's execute this. I'm saving it. Let's execute this. Okay. I'm fixing some compile errors. Let me execute this. Why I'm getting this many errors? From something s1. Okay, so this is the error. Print ln. Okay, let me do a comment on here and print it again. From hello print ln, something is missing here, so let me copy it from here. I don't know what is happening. Okay, I'm executing it again. Let me remove this, run it again. Okay, now this is working fine, and let's have some changes. Execute it. So these are the warnings, and okay, let me go. Okay, so here we can see could not compile the ownership. Okay, so here this is coming because we are actually passing something called the s1. Okay, so here we are passing the s1 here, and the s1 is passed to this particular function. Okay, so here this is the same way as we discussed earlier, like s2 equal to s1 scenario. Okay, so in that case there is another method that is called the borrowing method. Okay, so we will discuss that particular method. So in the borrowing method, what is actually happening is we are not changing the ownership to a function. Okay, so instead of, we are just passing a reference to, not a reference, a not a ownership, just passing some kind of a, what we called a scope to it. Okay, so for that what we can do, we can just rewrite our program something like this. Okay, so instead of just passing the s1, okay, just passing a handler to it. So for that I can change it to and can be passed here. Okay, and here also I can do, instead of s1, just pass the string. Okay, so this is actually called the borrowing. Okay, so let's execute this. Okay, so when we do something like this, what is happening is that we are only passing the pointer to this particular function, not changing the ownership. Okay, so that is why when we, after executing this, we are able to run this particular s1 here. We are able to print the s1 also here. Okay, and there is another problem with respect to this borrowing. Okay, the problem is what happens if you try to change that something here in this method. Okay, in the something method, what happens if I am do some kind of a changes. For example, I have s1 here. Okay, so I'm calling s1 and I am going to do some kind of a push str. I can do push str, and I am saying world, something like this. Okay, now let's execute what will happen. Okay, so what it says that s1 is a reference. S1 is a reference, not the data is so the data it refers to cannot be borrowed as mutable. Okay, so the reason why is we are not sending the ownership, or we are not sending any reference. We are just sending some kind of a borrowing kind of a thing, right? So in that case we will not able to change this exactly. Okay, for that what we need to do, we need to make some kind of a mutability here. Okay, for that what we can do, we can just add, let s mute here. Okay, and here also let's make mute string. Okay, now execute it. Let me see, could not compile the ownership due to previous error. Something is there. This s1 mute and string. And here I am printing the s1 dot push str world. Okay, here also I need to make a change. Instead of this, I want to send this as a mute. Okay, here we can see this is working as we expected. Okay, so here we can see I am sending the s1 and the mute is also added, and I am printing it here. That's why we can see the hello, and I am updating this into the world. Okay, then I am printing the hello world here. Okay, so this is working as we expected. Okay, so this is the basic idea with respect to the ownership, and I hope like I have explained in detail with respect to the ownership, and this is the high level explanation that I have made. More details that we can expect in our coming videos. So that is all about in this video. Please do like and subscribe. Have a nice day. Bye bye.